me. Homework 3, number 6. Okay, number 6. This is about finding the surface area. For number 6, the function y equals x to the third plus 1 over 12x and x between 1 and 2 about the x-axis. About the x-axis. So this one tell you that it's going to be the term with respect to x, or the thickness is going to be delta x. Okay, the interval in x already provided from 1 to 2. The formula, the surface area, which is the integral from point A to point B, 2 times pi. If it's from the x-axis, so gonna be y equals 0. So the measurement from the top of the graph to the x-axis is just the y function. So gonna be the function y here. Let me write in the term f of x. So this is the function y. So this is circumference. And the y here is the radius of the curve, the radius of the solid of revolution, or of the band that wrap around. And multiply by the segment length, which is square root of 1 plus y prime squared with respect to x. So ask yourself, what do you need? You already have the y equals x to the third plus 1 over 12x. You're going to need y prime and y prime squared and 1 plus y prime quantity squared. Similar to what we need to get done on the side before you put in the main problem as the problems in the section 6.5. Okay, this problem is the algebra. It has algebra term. I will add another slide to give you more room here. Okay, add more. From the terms that we have y equals x to the third plus 1 over 12x. Your goal is to find y prime, right? And then y prime squared. And then 1 plus y prime squared. To find y prime, I'm sure you know how to find the derivative x to the third and 1 over 12x, just to make it in the more manageable way. So I'm going to rewrite this as x to the third plus 1 over 12, x to the negative first, because I see the power clearly. And then what I have to do, I find y prime. Y prime is 3x squared plus 1 over 12. The derivative of x to the negative first is negative x to the negative second. So I rewrite it in the better form as 3x squared minus 1 over 12, x to the negative second. I get my y prime. Next, I'm going to work on y prime squared. So y prime quantity squared, which is the quantity of 3x squared minus 1 over 12, x to the negative second, all squared. Perfect square again, right? Similar to the process that we're going to use as what we used back in the previous homework and previous problems. So we're going to do perfect square. The first term squared, which is 9x to the fourth. The last term squared, which is 1 over 144, x to the negative fourth. The middle term from double of the product with the same sign. Double of the product, the 3x squared, and 1 over 12, x to the negative second. Exactly same technique, okay? And then I'm going to clean up the middle term. I see 2 times 3 at the 6, and 6 and 12 reduced to be 1/2. I have negative 1 over 2, and then x to the negative second and x to the second. When you multiply to get x to the power 0, which is 1, that means the middle term comes down to just the single number, no variable. and added by the last term, which is 1 over 144 multiplied by x to the negative 4th. So this is y prime squared. And next I'm going to work on 1 plus y prime squared that I just got. So 1 plus y prime squared, which is 1 plus 9x to the 4th minus 1 over 2 plus 1 over 144 x to the negative 4th. It comes to the same pattern as the problem that we worked on in the last section. 1 minus 1/2, that becomes positive 1/2. I will write it as 9x to the 4th plus 1 over 2 plus 1 over 144 x to the negative 4th. As you see, they have exactly the same three terms except the sign in the middle here, from negative side to positive side. What you got for y prime squared is from square of 3x squared minus 1 over 12 x to the negative second. Therefore, the one that we just got from adding 1 to it is the same as the quantity squared of 3x squared plus 1 over 12 x to the negative second. Just change the sign from negative to positive. So you get exactly the same three terms except the sign in the middle switched from negative to positive. Okay, now I'm going to rewrite this. That means my 1 plus y prime squared in the nice form as the perfect square of 3x squared plus 1 over 12 x to the negative second. I got all my pieces here. And what I'm going to do next, I'm going to work on putting back into the problem. And the problem is to find the surface area in the form of the integral from 1 to 2, right? From point A to point B, and 2 times pi. The radius for this case is the y function. So I'm going to point it out here. This is the radius, which is the f of x, or the function x to the third plus 1 over 12 x. So that's the radius. And then multiply by the square root of 1 plus y prime squared, which we already simplified to be the power 2 of 3x squared plus 1 over 12 x to the negative second. Let me rewrite it. So plus 1 over 12 x to the negative second with respect to x. And fall into the same idea that square root 2 and square, they cancel. No, the square root and power 2, they cancel each other out. And our problem now becomes just the what do you call, not the polynomial, the product of the two binomials. I'm going to move 2 pi out of the integral side, 1 to 2. And now the integrand is the product of x to the third plus 1 over 12x and 3x squared plus 1 over 12 x to the negative second with respect to x. And then from this point down, I'll let you finish it. Okay? How to handle this? Give you one more hint. Distribute the terms until you get the expanded form. And after that, you do the antiderivative term by terms. And keep in mind for the sections, when you find the volume, the arc length, surface area, they all have to be positive number. Okay. If you come up with a negative result, something wrong with your setup, go back to check your work. The good thing about showing all the work is when you find something that doesn't sound right, it's easier for you to go back to look at your old work and then keep track it down, which part that you do you have to fix, or something is missing, something like that. Okay, so that is one of the problems about the surface area about the x-axis.